Hi everyone and welcome to today's tutorial. Today we will look at the solution of this radical equation. X root x is equal to x plus root x. We want to get all the solutions. That is, we want to get the real solutions and the complex solutions. All the solutions for this radical equation. So please watch the video from beginning to end because a lot of insight will be brought in for us to get all the solutions of this radical equation. So let's start. Our equation is x root x is equal to x plus root x. Now we have the radical on the left hand side and the radical on the right hand side. So let's proceed by first of all taking this x on the right hand side to the left hand side. We have x root x. This is positive x coming this way. It becomes minus x is equal to root x. Now let's remove this radical. The opposite operation of square root is square. So we're going to square both sides. Now we will not just come and cancel this out, which is still correct, but we want to make use of the difference of squares identity. Alright, so we just carry this one from the right hand side the way it is into the left hand side. So we have x root x minus x all squared minus root x squared is equal to 0. This gives us a difference of two squares. This expression is a square. This other expression is a square. Now we apply the difference of squares identity. In that identity, all of this will stand for A. All of this root x will stand for B. So let's follow the identity strictly. If we follow the identity here, we're going to obtain x root x minus x minus root x. Alright, multiply to x root x minus x plus root x. That product giving us 0. We have the product of this expression and this expression giving us 0. So either this is 0 or that one is 0. So either x root x minus x minus root x is 0 or x root x minus x plus root x is 0. We have these two cases to solve. Let's start with this first one. If we look at this first one, we can see that root x is common. There is root x here, there is root x here, there is root x here. These ones are already there, but let's put this one. X can be written as root x squared. So let's write this one again as x root x minus root x squared minus root x is equal to 0. So that we can factorize out root x. We will factorize out root x. Okay, so we're going to get, we'll factorize out root x from here, we'll have x. Factorize out root x from here, we'll have negative root x. Factorize out root x from here, we'll have negative 1 is equal to 0. Here again, we obtain the product of two expressions giving us 0. So either this one is 0, and if that's the case, it simply means that x is 0. This is our first solution. Or this other one is 0. That means x minus root x minus 1 is 0. Now, if we look at this carefully, we will see that this is actually a quadratic. Okay, Let's make space and solve it up there so that it will be a lot clear. Let's write it again. X minus root x minus 1. X minus x minus root x minus 1 equals 0. It is a quadratic in terms of root x. Remember, x can be written as root x squared. So we just continue here. Minus root x minus 1 equals 0. Alright, so we can see the quadratic there. To make it better, we can make the substitution y equals root x. So that wherever we see root x, we put y. So this one becomes y squared. We have y squared minus y minus 1 is equal to 0. We see this quadratic in terms of y. If we collect our coefficients, a is 1, b is -1, c is -1. Okay, so from here we'll use the quadratic formula. Y will be equal to minus b plus minus the root of b squared minus 4ac all over 2a. Let's put our values carefully. So have y is equal to minus 1 plus minus the root of minus 1 squared minus 4ac all over 2 times 1. Now when we evaluate this carefully, we're going to have minus minus becomes positive. We're going to have 1. Y is equal to 1 plus minus the root of -1 squared is 1, negative positive, so plus 4 all over 2. So this is going to give us 1 plus minus the root of 5 all over 2. So we have y is equal to 1 plus minus the root of 5 all over 2. But remember, we were not asked to solve for y. We're asked to solve for x. Our equation is in terms of x. So we have to go back to that, our relation, the relation between y and x. We'll work again with that relation to be able to get the values of x. So y is root x. That means that when we put root x here, we'll have root x is equal to 1 plus minus root 5 all over 2. To get x, we simply square both sides. We square here, we square there. That will give us the values of x, the other two values of x. X becomes 1 plus minus root 5 all over 2 squared. This gives us two other values. Remember, we had the earlier value. The earlier value was x equals 0. This gives us two other values. So far we have 3 solutions, and all of them are real numbers. So we've seen the first 3 real solutions. X equals 0, x equals 1 plus root 5 all over 2, and x equals 1 minus root 5 all over 2 squared. Alright, we have solved that first equation. Let's take the second equation. The second equation we have to solve is x root x minus x plus root x equals 0. That's the second equation we have to solve. Again, we see root x is common. We can always write this as root x squared. So we have x root x minus root x squared plus root x is equal to 0. Okay, now we'll factorize out root x. Since root x is common, we'll factorize out root x. It will be root x into x minus root x plus 1 is equal to 0. Now we have a product of two expressions again giving us 0. Either root x is 0, in which case x must be 0. Again, this just comes to confirm our first solution. Our first real solution was x equals 0. Now, we also have this one, x minus root x plus 1 equals 0. Again, it's also a quadratic in terms of root x because this one is written as root x squared minus root x plus 1 is equal to 0. So if we still do that substitution, maybe we'll take a different letter now. Let's call it p. Let p be root x. So wherever we see root x, we'll put p. So we're going to have p squared minus p plus 1 is equal to 0. This is a quadratic in terms of p. We'll collect our coefficients. A is 1, b is negative 1, and our constant c is positive 1. Now let's put that in our quadratic formula. That will mean p is equal to minus b plus minus the root of b squared minus 4ac all over 2a. Let's put in our values carefully. It's going to be minus 1 plus minus the root of minus 1 squared minus 4 into a c. Our c is 1 all over 2a. This gives us minus is positive 1 plus minus the root negative 1 squared is 1. 4 times 1 times 1 is 4 all over 2. This gives us 1 plus minus the root of 1 minus 4 is negative 3 all over 2. So these are the values of p. P equals 1 plus minus root negative 3 all over 2. But we know that root negative 3 is root of negative 1 times 3, which is root of negative 1 times root of 3. But we know that root of negative 1 is the imaginary number I. The imaginary number I. Such that root of negative 3 now becomes I root 3. So our P becomes 1 plus minus I root 3 all over 2. Okay, so but we have to solve for x, not p. Okay, we remember that p is root x. If we put it there, we're going to have root x is equal to 1 plus minus I root 3 all over 2. To get x, we simply square both sides. When we do that, we obtain x is equal to 1 plus minus I root 3 all over 2, all of this squared. Okay, so this gives us the remaining two solutions. So the remaining two solutions are actually imaginary or complex values. All right, so x has 5 solutions, 3 real solutions and 2 complex solutions. So let's write down all the 5 solutions again that we got. So x root x is equal to x plus root x has solutions x equals 0, x equals 1 plus root 5 all over 2 squared, x equals 1 minus root 5 all over 2 squared, x equals 1 plus I root 3 all over 2 squared, and finally x equals 1 minus I root 3 all over 2 squared. 1, 2, 3, 4, 5. These are the 5 solutions of this our radical equation x root x is equal to x plus root x.